We've talked about domain and range in earlier lessons, but now we're going to get into much more detail. So this is domain and range of a relation. Some might be functions, just be relations. So it'll either be discrete, so we'll be listing out the domain or range values. It might be continuous data, or an equation of a line, or a curve that can be graphed, then we will maybe have to use inequalities to describe the domain and range. So take a look at the notes. It says a relation can be represented as a set of ordered pairs. The domain of a relation is a set of all the, remember those are all the first elements of the ordered pairs, and the range is the set of all the second elements of the ordered pairs. Recall that a relation is a function if each element of the domain is paired with exactly one element of the range, right? So this is your definition. You're asked on a test. That's what it would be, okay? Domain and range for discrete data. So we're just starting with discrete, which can be represented as a set of ordered pairs, a table of diagrams, an arrow diagram, or even just discrete points on X and Y coordinate grid. So question 1, for each of the following state the domain and range and whether or not it's a function. So domain, we use the squiggly brackets, which are really the set brackets. D for domain equals, and then list them. Now you can put them just in the order they're written. Turns out that that's numerical order anyway. If they weren't in order, you could rearrange them. So then range 4, -2, so those are kind of split up, right? So I'm going to look for the smallest one is -2, and then we've got 2 4s, but I'm only going to show one of them, and then 5, and then 8. Okay, you don't repeat the 4. It is a range value. 4 is 4, doesn't change. Okay, so that's domain and range. Domain for the next one, we list out the names. Okay, it's not numerical, but it doesn't matter. And then the range happens to be numbers, it's shoe size. And again, here I'm going to put them in order. Okay, does it matter? No. Is it easier for me to mark if you put it on a test? Yeah. Okay. And really, when you go to an arrow diagram, that's when we do put them in, well, for names, there's not really an order. We could have put them in alphabetical order, but for numbers, always put the numbers in each oval in order, okay? And that's where what sets it out is the arrows, what's related to what. Okay, so this in this case we're doing, oh, you know what I forgot to do is to go back and state whether they were functions or not. So I'm back in A. Remember, there were no repeated x values. So for every x, there was only one y. So that's a function. Here, no repeated x values for every x. There's only one y. Okay, next one here. All right, so our domain is really everything that's in the ovals. So Tim, Jim, Sharon, and Hal, and then the range, everything that's in the oval. It's oval, right? Okay, and then from there, there's no arrows that start twice at a name. There's just one arrow from each name, so that's a function. Okay. Next one, domain. We need to look at the x value of each of the points. So I'm going to start from the left. So we've got x equals -3, and then -2, and then 0, and then 1. And then the range, I'm going to start from the bottom. Oh, sorry. And this one, there's a 4 there as well. Okay, the range from the bottom, the smallest y value is -3, then -2, then 1, then 2, then 3, then 5. okay? And taking a look at this, these points are above each other, above and below. They're on the same vertical line, so this is not a function. Okay. Next one, this represents ages and masses of people. So here, domain, as best you can, look at the scale. So that looks like 4. And then this would be 6, so halfway in would be 5. And then it looks like 8, 12, 14, and 60. Okay, and then the range looks like 20. Now this would be 30, that looks halfway in between, so about 25. And that looks like 45, and 65, and 80, and 85. Okay, and none of those are on vertical lines, so this is a function. All right. All right, so now let's look at non-discrete data. So these will be on graphs usually, or maybe an equation is given to you. So for non-discrete data, it is not possible to list all the data values of the domain or range of a relation. In these cases, we will need to use symbols. So inequality symbols. Notice this funny looking E, that's a Greek E, it means element of, and equal signs to describe the domain and range. So we're going to start in grade 10, make sure that you have the notation down pat, so that you've got it set for when you write the math diploma exam in 30-1, because there is a written component on that, and it's important that it's done correctly for full marks. So it used to be, just so you're aware, some of our answer sheets in the Schoology site may not have the entire domain or range set out completely, because it used to be that Alberta Education was a little bit more lenient, but now it's not. So that's why you'll see full on domain and range in this video. Okay, so domain at all the x values. So I always kind of start looking from the left. Where is my first x value from the left? In this case, it's when x equals 3. And then it's continuous to the right, both ways, with an arrow on the end. So an arrow means it keeps on going in that direction. So x will keep on going. So in this case, so our domain here, we can put equals because the word's already there, our set bracket, and this is where we have to put whatever variable is being used for your domain, so x, with a vertical line, okay? So what that means is such that, or where, okay? So this says domain is the set of all x values where x is greater than or equal to -3. And then we need a comma to say that x is an element of the set of real numbers. Okay, so that's kind of a funny looking R. Oops, that's getting messier. So I do it with 2 vertical lines, which represents set of numbers. Okay, in some textbooks you'll see it bolded, but it's hard to bold when you're writing things out. Okay, so sometimes we abbreviate it just to this if we're working quickly, but on a test you want to do the whole thing. Okay, take a look at the range. My smallest y value as I'm going up, well, this arrow is going down and to the right. So that means there is way over here, there's a point, right? So this goes from -infinity all the way to +infinity. So these arrows can go forever. So when that occurs, when basically y can be any real number, then we write all values of y where y is an element of the set of real numbers. We don't need an inequality. Okay, don't start putting one in, it gets too confusing because you're trying to show all real numbers, and that's what you want to show. Okay, is this a function? No. Okay, because of that vertical line test. Next one is a vertical line. So this is kind of interesting in terms of the domain. If you take a look, if I'm going from the left or from the right, the only x value that I get in all of these points, anywhere in between, is -4. So this actually is just one value, so I can put it in my set brackets and list it. Okay, but the whole relation is continuous because that's a line, a vertical line. So my range, then I look at my y values. Well, this arrow is going down, so it's going to go to -infinity. But up here, I don't have any y values above. The first possible value looks kind of like 5, except it's an open circle. So that means it's going to be everything less than 5. So now my range is all values of y, where y is less than 5. I don't put the equal sign in because it wasn't a filled in circle at 5. Then y is an element of a set of reals. Okay? And this is not a function. That is a vertical line, so there's no way it can be a function. Okay, next one is basically an application question. Looks like comparing someone's weight to how old they are. So the domain here, take a look at if there's a variable used, it's a. So all values of a where. Now it's continuous, so we need inequalities, but notice how there's no arrows on the end. So it really starts at this value and ends at this value. Okay, so take a look, that's starting at 10 and ending at 45. So this we need to have an inequality with boundaries. So I put the smallest number in first, biggest number to the right, and these are for my a values. Okay, so this is called a compound statement. So a is less than or equal to 45, greater than or equal to 10. So you want to look at the mouth of the, I'm old school, Pac-Man eats the biggest thing, right? So what's the biggest in these numbers? 45. So a has to be at the small end of that, but that value of a at any point has to be bigger than 10 or equal to, okay? And then we have a element of the set of reals. So that we call a compound statement. Range is going to be kind of similar to that. We have to look, here our range is W, and we want to look for our smallest W value, so 30, and here it looks like 60 is the biggest. So now I write out my 30 first, and my 60 second with space in between. My W goes in between with inequalities always going the same direction towards the biggest number. If you do that, always put the smallest number first, biggest number at the end, then your inequalities are always opening to the biggest, to the right. Okay? And then W is an element of the set of reals. And that is a function. All right, next part. Next side. State the domain and range for each of the following relations and whether or not it's a function. Use the appropriate values. So we're doing more of the same, right? So here, domain is continuous, so we're going to need to use inequalities. My leftmost value is -1 and my right is 6, and it's joined with a curve. So that means you take a look, X is what you're doing for your independent, your horizontal. And so I want to write my smallest and my largest with X in the middle, opening towards the biggest number. Okay, X is this element of the set of reals. Then Y is for range. In this case, it's Y. So my smallest is -3 and my biggest is 1, right? When you look over. So -3, 1, y goes in between with inequalities opening to the right. This does not pass the vertical line test. For example, here, there's 2 points with the x value of 3, so this is not a function. Oops. Sometimes we abbreviate function to fn, okay, or fun. Math is fun. Functions are fun. Okay, so next one, domain. Take a look, it's T. And then leftmost, you can't see, it stops at this point, right? So there's no arrows, so it has endpoints. So the smallest x value is 0, biggest is 4. So 0, 4, T goes in between, opens to the right. T element of the set of wheels. Range, smallest is 0, biggest is 80. So range is h for height. So 0 to 80, h in between, inequalities, h element of the set of wheels. Okay. Next one, take a look. This x for your horizontal, and there are arrows on both ends. So this is what we call an oblique line. It goes on forever, up and to the right, okay, down and to the left. So it will cover all x values from -infinity to +infinity. So that's where we say x is an element of the set of reals and you're done. That will cover every single x value. Decimals, fractions, repeating, non-repeating, irrationals, all that kind of stuff. Range is y, and same thing, the arrows are going down and up, so y is a set of, y is an element of the set of real numbers, okay, and that's a function. And that will be, we'll do a whole unit on linear functions, and they'll all be similar to that, all real numbers, okay, unless it's a vertical or horizontal line. Next one is actually what we call a piecewise function. It's sort of 2 lines, 2 linear functions joined up. Actually, this is not considered a function here. You take a look at this right away, this part here, it's a vertical line. So right away, we know it's not a function, okay, because of that. In terms of the domain, it's not labeled here, so we're going to assume it's x and y if it's not labeled, because that's sort of your default variable. So all values of x, and let's check it out. So if I'm going from the left, I've got an arrow here. So this is going to go to -infinity for x. But as I go to the right, once I get to 2, then there is nothing past 2, right? So 2 is the biggest number, and I want everything less than or equal to it. So we want all the values of x where x is less than or equal to 2 and a real number. Okay, then range is all y values. Take a look at the y, that arrow is going down, vertically down, so you know it goes to -infinity. Up here, it's going upwards, slowly, but it is, so it's all real numbers. So this is y is this set of, is basically similar to that graph that we looked at a couple of videos ago, a couple of lessons ago, where we were determining time from the speed. And so we took whatever distance was given, in that example was 120 kilometers, and determined, based on different speeds, how long it would take to travel that 120 kilometers. So looking at this graph for our domain, our variable is s. Try to not make it look like a 5. And so domain here, this arrow is going to the right, so it's going to +infinity. But here, this arrow is going kind of vertically, not quite. It's approaching that vertical axis, but not touching it. It's never going to be over on the left of it. It's never going to be a negative speed, and it's never going to be a zero speed, because if you're traveling at zero speed, you can never get that to that 120 kilometers or wherever it is you're going. So that means it's everything greater than zero. So this would be S greater than zero, where S is an element of the set of wheels. Now, ideally, in a vehicle, there's a limit to how fast a vehicle will travel. So we're just kind of generalizing this. If there wasn't a limit to that, there was no friction, there was no traffic, all that kind of stuff. Okay, and then the range is for time. Same thing. So if we take a look at time, the arrow's going up, so it can go to a maximum time. It can take you forever, but it's not going to be zero time. If it was zero time, that means that you wouldn't have to be going to speed. It would be like you can time travel. So it's going to be t greater than zero. T element of the set of wheels. Okay, and in this case, it is a function, because there's no vertical line that can be drawn and touch more than once. Okay, and then the exercises, we'll go through these quickly. State the domain and range of each of the following. Also state whether the relation is a function or not. So set of ordered pairs. So 0, 2, then I'm going to put 5 and 8. So all the first elements of the set of ordered pairs. The range, I'll put in order. -3, -1, 5, and 7. And you want to check your first values. They're all different, so yes, it's a function. Okay. Here, domain, smallest is -3, then 40. I don't repeat the -3. There's 2 of them, but I only show it once. Range is 4, 5, and 6. Okay, and because I have 2 x values that are the same, and they're different y values, this is not a function. Okay, and really a non-mathematical. So domain here would be Susan, Jill, Lucy, and Steve. And the range would be F, M. Okay. And so function, we want to look, is there a repeated person? No. So this is a function. Okay. Arrow diagram, the domain, just copy out what's in the oval. Range, copy out. And take a look, there's 3 arrows from the -4, so this is not a function. Okay. Then the next is discrete, a graph. X values, there's only -3. All of those points have the same x value, but they have different y values, -2, -1, 0, 1, 2, 3. And they're all in a vertical line, so no, it's not a function. Next one is an application. Domain is, but it's discrete still. So domain here, take a look at your points. So 0, 10, 20, 30, 40. Your range, that would be 50, 100, 150, 200, 250. And the function is it a function? Yes. Okay. Vertical line test. And so remember, for lines like that are not horizontal and vertical, all real numbers is your domain. X is your domain value, your range is Y in this case, and Y is all real numbers. Okay, because you can extend that forever and get any X value or any Y value. Is that a function? Yes, it is. Okay, next one, notice how it doesn't have arrows on the end. It actually has endpoints. So that restricts the domain. So the smallest X value here is -4, and the biggest is 5. So remember, I put those at each end. X goes in the middle, less than or equal to in both. And then X element of the set of reals. Range, Y values, smallest is -1, biggest is 2, Y goes in the middle. Inequalities, Y element of the set of reals. Okay? If you do it like that, lowest value, highest value, then the variable in the middle, then you're always, inequalities are always opening to the right. Function, yes. Okay. Next one is representing an application. So domain is D, it's continuous. So we have to use that D first. And then smallest value is 0. And biggest, we need to look at the scale. So 1, 2, 3, 4 for every 300. So 4 grid markings for every 300. So this is, we want to divide, so this here would be 900. So basically 300 divided by 4. So 300 divided by 4 is 75 times 3, right? We'll get you 225 plus 600 is 825 is going to be that last value. And that's D in between, inequality signs, D element of the set of reals. Okay? Then range is, in this case, capital L. Smallest is 0. And biggest, again, what is this scale? 1, 2, 3, 4, 5. So 10 for each grid marking. So that's going to be 130 there. Okay, so that's going to be from 0 to 130. Capital L, inequalities, L element of the set of reals. And this is a function. It's a line, right? I can just put yes. Okay, next application. Domain is T is continuous, so I have to have my T, vertical line, and again, no arrows, so the smallest T value 0. The biggest one, well, let's check the scale. 2 grid units for every 1 second. So this would be 4.5 seconds. So I'm going from 0 to 4.5, T in between. And then range, smallest is 0, and maximum here is, so what's the scale here? 1, 2, 3, 4, 10. So that would be 110 there. So this is going to be H, where we're going from 0 to 110, and this is H element of the set of reals. Function, yes. Okay. Next one here. This is actually an absolute value function. You'll talk more about this in Math 20. But the domain arrows, if you take a look, they're going down and to the left, down and to the right. If they're going left and right, it's going to be all real numbers. And X is our variable, so X is a set of real numbers. But range, there's no points above the x-axis. Arrows are going down, but the largest y value is 0. So for the range, it's going to be y less than or equal to 0, where y is an element of the set of reals. Okay? And is it a function? Yes, it is. Okay, vertical line only touches once. Domain in the next one, again, it's continuous. It's with x. And notice how there's a point here, but an arrow here. Okay? So no x values to the left of -1. -1 is the smallest, and it's everything greater than, because it keeps on going to the right. So x is greater than or equal to -1. I have to squish it in here. Oops. And then x is an element of the set of reals. Range is y values, and y has to be greater than or equal to 2, where y is an element of the set of reals. 2 is the smallest value, and the arrow is going up. And that's a function. Okay. So we've done those ones. Next page. Okay. This is kind of, we've done similar where it opens to the right. This opens to the left. It's continuous. So we have x. But here the arrows are going to the left. So the biggest, there's no x values over here. The largest value of x is 3. So x is less than or equal to 3 and an element of the set of reals. In terms of the range, the arrow is going down and to the left and up and to the left. So down and up covers all real numbers. So y is an element of the set of reals. And this is not a function because if you draw a vertical line anywhere there, you get cuts it twice, at least one place. And it's infinite number of places in that one. Domain, this one's a horizontal line. So the arrows are going left and right. Okay, so that's going to be all real numbers. It is continuous. But the range, all of those points, sorry, my graph is off. All of those points have a y value of 4. So there's only one y value. So we just list it. Okay, and this is a function. Any vertical line just touches it once. Okay. Distance from home. So this it's continuous, and our domain variable is t. So all values of t where, and then there are no arrows. So that's an endpoint, and this is an endpoint here. So we're going from 0. Got to look at the scale. So 1, 2, 3, 4 for 8. So every grid is 2. So this would be 26. So this is between 0 and 26. T in between. T element of the set of reals. Okay. Then range. Y value there at the bottom there, that's 0. And the largest, if we go across here, is going to be what? So 1, 2, 3, 4 for every 20. So that means each grid unit is 5. So that's going to be 70 there. So this is going to be, and the variable is d. So from 0 to 70, the element of the set of reals. Okay. And then that is a function. Okay, and then vertical lines in that one. Next one is a circle. So smallest x value is -2, biggest is 4 here. Continuous. So x, so from -2 to 4. Okay, and then for the y, the smallest value is -3, the biggest is +3. And this is not a function. Circles are not, because if I draw, you can tell right there, I've got 2 points that have the same x value but different y values. All right, anything that has a dotted line like that is what's called an asymptote. So that's not part of the graph, but it helps describe that this curve here gets really close, it's not great, but really close to that x-axis, but doesn't touch it. Okay, so for the domain, we're dealing with x, and if the arrow is going to the left and to the right, it's all real numbers. So that's pretty easy in this one. For the range though, which is y, because of that asymptote, there are no points below the x-axis. There's no points on the x-axis because of the asymptote, but there is a point right above the x-axis, some decimal value. So basically, we need to use an inequality, but don't include the equal. So it's y greater than 0, because it does keep going upwards, where y is an element of the set of reals. okay? And this is a function. All right, and then last one, this one is an equation. It says to graph it. So if you don't have a graphing calculator, that's okay. I'm going to do it here, but just be aware of the properties. And this is a good introduction to graphing. So go to y equals, if you have a TI calculator, somehow you go to y equals, just a sec. Let me just see. Okay. Y, oh, you know what? I think, yeah, my alignment's a bit off. So y equals, and then bracket, x plus 4, close the bracket, squared, minus 5. Okay, then it says for the window, so then we go to window key, and we change it to -10, which the first one's already -10, so just press enter on it. Then 4, enter, 2, enter, then -6, enter for y, 16, 2. That's just giving it its scale and minimum, maximum x and y values. So now if we press graph, it's going to graph that for us. And you can see it's a U shape. It's called a parabola. Anything that's x squared will have some kind of shape like that. Okay, so we've graphed it. What's the domain? Well, basically, remember in this form, if you have y equals, then you can put any x value in here. Okay, you'll get just one y value out. If you take a look at the graph, then it doesn't have arrows because it doesn't have that possibility, but you could move this or change the scale and still get more values going up and to the right and up and to the left. So the domain is, if you're going left and right, you know it's all real numbers. The range though, there's nothing below that bottom point of the U, right? And so we need to check and see what that value is, okay? So you may not know how to do it. Basically, it is this value here, the -5, and you don't need to know this right now. But if you wanted to find that minimum point, you go second, trace, down to minimum. And then you cursor, it says left boundary. You cursor until you're to the left of where you think it is. Enter on that, cursor to where you are to the right, enter on that, and enter when it says guess. And the y value there is -5. So this is all y values that are greater than or equal to -5, where y is an element of the set of wheels. And it's a function. So we ended it with something a little bit different, but nice to get an introduction to graphing on your calculator. Okay, so that's it.